All right, new designers, we're going to be talking about the moon today. The launch question, I just want to start off with a couple of facts. Firstly, the moon is the closest major object in our solar system to the Earth. But just to give you an idea of how big space actually is, even though the moon is the closest thing to us, it's still about 239,000 miles away. That is so far away that you could fit all of the other planets in our solar system in between the Earth and the moon and still have some room to spare. I think that is just insane. In our next lesson, you're going to be hearing from Jordan. He's going to be teaching you a little bit more about the other planets and objects in our solar system. So you'll talk a little bit more about that in our next lesson. All right, but back to the moon. Today we're going to be talking about moon phases. And by phases, we mean the different shapes that the moon appears to take throughout the course of the month. So the moon appears to change shape in a predictable way over the course of about 29.5 or 29 and a half days. So these are typically the phases or the shapes of the moon you'll see throughout the entire month. And the reason why the moon appears to change shape throughout the month is because the moon is revolving around the Earth. As the moon moves around the Earth, we see different portions of the moon. All right. So, like all the other objects in the solar system, including the Earth, half of the moon is always being illuminated or lit up by the sun's light. We just don't always see all of the lit up half of the moon. All right, so all the objects in our solar system, the half of the object that's facing the sun is its daytime, and the other half that's facing away from the sun is experiencing nighttime. All right, so as the moon is revolving around the Earth, even though half of the moon is always lit up, we're seeing different angles, we're seeing different amounts of that lit up portion of the moon. So because of that, the moon appears to change shape throughout the month, although it's really not. We're just seeing different angles of the lit up half of the moon. Right? So we call this the lunar cycle. And the reason why you're going to hear the word lunar a lot is because luna is just another name for moon. Luna is actually what you call moon in Spanish. Right? So lunar module, lunar landings, that's all talking about moon stuff. All right, so even though it takes about a month or 29.5 days for the moon to go through one cycle of these phases, it actually only takes slightly less than that to revolve around the Earth. It only takes about 27.3 days to get around us. And this over here is a chart you're going to be learning a little bit more about in our next lesson. It's from page 15 of the reference tables, and it's called the Solar System Data Chart. So it has a bunch of information about the Earth and all the other planets, and at the very bottom of this chart, you'll see information about Earth's moon. So this column over here is called period of revolution. It tells you how long it takes each of these objects to get around the sun. Except for the Earth's moon, this is telling you how long it takes for it to get around the Earth instead. So 27.3 days to do one orbit, but it takes 29.5 days for us to see one full cycle of phases. So why the difference? Why does it take an extra day and a half or 2 days? It's because while the moon is revolving around the Earth is also at the same time not standing still, but also moving in its revolution around the sun. So it takes about a month for the Earth to go from here to here. And if the moon does one full orbit in that time, it still needs to move an extra day or two to get realigned back up in between the Earth and the sun over here. And that'll make a little more sense in just a second. All right, but as long as you know it takes about a month or 29.5 days to see all of these phases, that's all you really got to know. All right, so moving on. Here is a really, really common diagram that is usually used to show the cycle of phases of the moon. So I'm going to start off with this image over here. This is a bird's eye or a top view of the Earth. Imagine you're a bird or an astronaut and you're flying over the North Pole and you were able to look down at the top of the Earth. This is showing the position of the moon as it orbits around the Earth over the course of that month. And then here we have the sun on the right side of this diagram. Sometimes they'll put the sun on the left side of the diagram, so just be mindful of that where the sun is. All right, so over here, they're showing you what the moon will actually look like or how it will appear from Earth on each of these positions. So here we call this the new moon. This is where we start the month. When the moon is in between the sun and the Earth, we don't see the lit up half of the moon. We actually see the dark side of the moon. So to us, that appears what we call a new moon. We don't actually see anything in the sky. It looks totally dark. It's actually the best time of the month to go try to look at stars because the sky is darker as a result of having less reflection of sunlight from the moon. So as the moon moves throughout its orbit around the Earth throughout the month, we see different phases as it moves on. And we'll talk about each one of these in a little more depth now. All right, so we're going to start with that first phase called new moon. So this is when the lighted or the illuminated side of the moon, is facing away from us. So in other words, the moon is between the Earth and the sun. So you're somebody standing on Earth, you're looking out of the moon, you can't see the lit up half because it's facing the sun. All we see is the dark half. We don't really see anything, so we call this new moon or no moon. Right? Every day after the moon will be what's called waxing, meaning that we're seeing more and more of the lit up side every single night. So about 1 week after that first phase, after that new moon phase, we have what's called a waxing crescent. A crescent moon is when you have just a little sliver of light, and when it's on the right side, we know that it's going to be getting lighter and lighter every day throughout the rest of the week, so we call this a waxing crescent. All right, about 1 week after where we started, or 1 week after the new moon, we're 1/4 of the way through our cycle. So we call this a first quarter moon, but from us on Earth, it appears like a half moon. The entire right side of the moon will be getting lighter and lighter as days go by. 1 week after the start, the entire right half of the moon will be lit up. So here's the sun, here's the Earth, here's the moon. They're kind of at a right angle. If you were looking out at the moon from this position, all you would see is this front half. So the right side would look lit up, the left side would look just entirely dark. All right, after this, the light is going to continue to grow and flood over towards the left side. So that's going to be what we call a waxing gibbous moon. A gibbous moon is kind of like a fat moon. It's not really halfway lit. It's not fully lit. It's somewhere in between. So here is our waxing gibbous. All right, so now 2 weeks after the start, we're about halfway through our moon phase cycle. We've reached the full moon. So now the moon isn't between the Earth and the sun. Now the Earth is in the middle. So as a result, the side of the moon that the sun is lighting up or illuminating is now facing us. So to us in the sky, it appears like a full moon, like the whole thing is lit up. So in other words, the Earth is between the moon and the sun. All right, so now after the full moon, it can't look any more illuminated or any more lit up to us. So now it's going to look like it's kind of shrinking in the night sky. And we call that the waning cycle of the moon phases. So now we still have a gibbous moon. It's still more than halfway lit up, but that darkness is kind of creeping across the right side now. The left side is what's lit up. So we know we're in our waning cycle. The moon is going to appear a little bit darker and darker and darker every night after this. All right, so about 3 weeks from the start, we're 3/4 of the way through our cycle of moon phases. So now we're going to see a half moon again, but the right side will be lit up, not the left side. Or the left side will be lit up, not the right side, sorry. All right, after that, the moon is going to continue to appear to shrink in the night sky. Here we have another crescent moon, just a little sliver of light, but it's only the left side that's lit up. So this is our waning crescent moon. All right, so then about 29.5 days or 1 month from the start, we're back to the new moon. We're back to the beginning, and the cycle will start all over again. All right, so it is actually possible to have 2 full moons in 1 month as long as that month has 30 or 31 days, and like the first or second day of the month is a full moon. All right, so that leads us into our second topic for today, which are eclipses. So an eclipse is the complete or partial blocking of light when one celestial body moves into the shadow of another celestial body. In other words, something in space moves in front of the sun, and it either blocks the sun's light from reaching the person looking at it, or it blocks light from reaching another object. And these eclipses, really importantly, are cyclic, meaning they happen in cycles, they repeat, and they are predictable. Astronomers know when eclipses are going to happen for the next 20 years, They know when and where they're going to happen for the next 60 years. They know when and where they're going to happen for the next 100 years. They can predict this almost into infinity. They are so predictable that there is this famous story about Christopher Columbus actually using a total lunar eclipse to trick some native people who were living in Jamaica in order to keep kind of feeding him and providing them with supplies. These native Jamaicans, they were kind of getting tired of Christopher Columbus and his people being there, and they wanted to kind of kick him off the island. And he knew a total lunar eclipse was coming, so he predicted it and kind of convinced them that their God was angry with them, and that unless they kept continuing to feed and clothe them, he would be kind of angry. And yeah. All right, so speaking of a lunar eclipse, this can only happen during a full moon. The name of the eclipse, in this case lunar, describes the object that's actually being blocked. So, for the moon's light to be totally blocked out, the Earth has to move in the middle, in between the sun and the moon, and the Earth actually blocks the sun's light from reaching the moon, and that results in an eclipse. All right, so here's a cool little time-lapse GIF of a lunar eclipse. All right, so it starts off as a full moon. You start to see Earth's shadow creeping across the surface. Eventually, once it covers the whole thing, the moon will appear red for a few minutes, and then the shadow will keep moving across until the whole full moon is revealed again. If you're a little bit interested about why the moon appears red during a lunar eclipse, there's a really good video on the last slide of today's lesson describing why that happens. All right, so a solar eclipse, in my opinion, the cooler eclipse, is when the sun is actually blacked out on the sky. So this can only happen when the moon is in the middle between the sun and the earth, when they're all lined up. So this can only happen during the daytime, during the new moon phase, when we only see the dark half of the moon. All right. So there's actually two different types of solar eclipses. There is a total solar eclipse where the whole sun gets blocked out. Then there's just a partial solar eclipse where only a portion of the sun gets blocked out. So for you to see a total solar eclipse, you have to be within what's called the umbra, or the inner darker shadow that the moon casts on the earth during an eclipse. So you got to be in this little window over here. For you to just see a partial solar eclipse, which is cool, but probably not as cool, you have to be in the penumbra, or the outer lighter shadow that is cast by the moon as it moves across the earth. So here's probably a better image of that. The sun is coming from this direction. The moon is blocking the sun's light from reaching the earth. It casts a shadow across it. So if you're within this outer shadow, you would just see a partial or a small portion of the sun being covered. But if you're within this inner darker shadow, you'll see the entire sun be blacked out of the sky. All right, so the last time that happened here in North America in the United States was a couple of years ago in 2017 in August. This is a really, really, really good video of what it would have been like to experience that in the state of Oregon and the West Coast there. So really, really encourage you to watch this video. All right, here's just some still images of the eclipse. So here you can see the moon kind of moving in front of the sun's rays, and then eventually it'll cover the whole thing. And you get what's called the diamond ring effect over here when the sun first starts to kind of creep out in that corner over there. So just to sum all that up, a solar eclipse, when the sun is blocked out, that can only happen during the daytime, during the new moon phase, when the moon is in the middle. But a lunar eclipse can only happen at nighttime, during the full moon, when the earth is in the middle. So if you have any questions about this later, definitely come back to this slide. It sums it up pretty well. So you might be thinking there is a full moon every month and there is a new moon every month. So why don't eclipses happen every single month? And it's actually because the moon's orbit around the earth is a little bit tilted. It's tilted by about 5 degrees. So the path that the earth takes around the sun and the path that the moon takes around the earth aren't perfectly lined up. So it's only a few times every year where the paths of both the moon and the sun's path across the sky line up perfectly. And here's probably a better image of that. So here's the moon revolving around the earth, and only every once in a while do they line up perfectly with the sun's rays. And that's when an eclipse can occur. So I actually did get to experience the last total solar eclipse in 2017. It was in August. We didn't have any school, so I was able to actually drive down to South Carolina, which is where you, or one of the places you had to be in that umbra, to be in that inner dark shadow, and to see a perfect total solar eclipse. So it was one of the best things I ever experienced. It was about 2:45 p.m. in the afternoon on a summer day, and it went almost pitch dark in the middle of the daytime. I felt the temperature drop about 10 degrees, which was kind of nice because in South Carolina, it gets crazy hot in August. You started hearing kind of insects like crickets and birds going crazy. They were probably pretty confused that it just turned nighttime randomly in the middle of the day. And it was just an awesome, awesome, awesome experience. I only had my cell phone camera on me. I couldn't really get any of those great photographs you see online. So this is my one little photo of the eclipse. You see the moon covering the sun over there. Here is a satellite image of that eclipse. Here was taken from what's called the GO satellite. And here you can see the shadow of the moon passing across North America. It kind of started up here in Washington and Oregon, moved across, and then went down across those southern states like South Carolina that I mentioned earlier. But if you did miss this eclipse, you do have an experience to see another one relatively soon. The next one that's going to happen in the United States will be in 2024 on April 8th. So here is the penumbra. Here is the umbra, and you can see it moving kind of northeast across North America. And believe it or not, it is going to cross New York State. So we live down here in New York City. If you want to see the eclipse in its totality or see the entire sun get covered, you're going to have to fly or drive a little bit north up here or a little bit west over here. All right, so in between these blue lines is where you can see the total solar eclipse. The closer you are to this red line, the longer the eclipse will be, the longer the sun will be blocked out by the moon. So if you are trying to go see it, the Adirondack Mountains up here might be a really good place to go to get a good view of it and try to get as close to this red line as possible. If you do get a chance to see that eclipse, never, ever, ever try to look at the sun without protective lenses on. Not just during eclipse, but ever. Your eyes are not made to take in that much energy and that much light. So what our president did a few years back during that eclipse is something you never, ever, ever want to do. You can take your glasses off during the few minutes when the sun is entirely covered. You're actually going to have to do that because, as I said earlier, the sky gets really, really dark. But once the sun starts creeping back out from behind the moon, you got to put those glasses right back on because you can really burn your retinas and even go blind if you stare at the sun too long. All right, last little bit for today. Believe it or not, the tides that the ocean experiences also have a lot to do with the moon. Sorry about that. So because the moon, as I mentioned at the very beginning of this lesson today, is the closest object to the Earth in space, it actually has the most gravitational pull on the Earth. And that's what tides are all about. It's a rise and fall of sea level that happens a couple of times a day because of things in space pulling on Earth's oceans through gravity. All right. So the moon is a primary cause of the tides, and the sun, even though it's so far away, it's so massive that it does also have an effect on our tides as well, but not as much as the moon. All right. So even though the sun is so much bigger than the moon is so much closer to the Earth that it does have more of an effect. So here, this is a place in Nova Scotia, Canada called the Bay of Fundy, and they actually experience the greatest change in tides throughout the day of any place in the world. So you can see these boats that are docked during low tide during the day, they're actually kind of laying on the seabed there. They're laying on the floor in the canal. But then over the course of the next 6 hours, the water is going to come flooding back in, the water is going to rise, and those boats will rise up to the top of these docks. So about every 6 hours, you get high tide. 6 hours later, you get low tide. 6 hours later, you get high tide again. And then 6 hours later, back to low tide. Right? So they are also, just like eclipses, very cyclic and predictable. If you know anybody who fishes or surfs, they're always looking at tide tables to know when it's good to go out into the ocean. Right? So high and low tides, they occur twice a day. They occur when the Earth is lined up perfectly facing the moon, and then the side of the Earth that's on the opposite side will also experience high tide. All right, so let's pretend we're looking over here. It'll be high tide for us. All right, 6 hours later, we're going to do 1/4 of our rotation. Now we're at kind of a right angle with the moon, so we're going to experience low tide over here. 6 hours later, We've rotated another quarter of the way. We're experiencing high tide again. And then 6 hours later, we're going to do another quarter rotation, and it'll be low tide again. So over the course of one day, or 24 hours, you're going to experience 2 high tides and 2 low tides. All right, that is our lesson for today about the moon. There is so much more I wanted to teach you about this. There is so much more we could talk about the moon, but we're kind of running low on time with our school year and our remote learning. So there are tons of links here about other stuff that I wanted to talk about. Some really cool short videos about the solar eclipses. Definitely take a second and take a look at least a few of these links. There's some really, really good information on there. But if not, I hope to talk to you soon and enjoy learning about the solar system in your next lesson. Take care, y'all.